Today in geometry, we're going to review how to divide radicals and rationalize the denominator. So remember that our quotient property looks like the square root of a divided by b is equal to the square root of a divided by the square root of b, as long as a and b are both greater than or equal to 0. So when you have the fraction underneath a radical, you can just simply separate that and make two separate radicals. There are several different ways to divide radicals depending on what the radical looks like. Sometimes you want to simplify the fraction first. So look at these first ones. I have the square root of 32 divided by 8. Well, I know that I can do that. 32 divided by 8 is 4. So this is really the same thing as square root of 4, which now I know the square root of 4 is a perfect square, so that's just 2. So my answer is just 2. If I look at number 2, the square root of 48 divided by 4, again, I can divide that and get a nice little number. That will divide and get me 12. So now I have the square root of 12. 12 is not a perfect square, so we need to do factor tree. So I can multiply 4 and 3 together. 4 breaks down to 2 and 2. I have a pair of 2's and a 3 that stays behind. So my answer would be 2 square roots of 3. The next one says the square root of 70 divided by 10. Again, I can divide that and get a nice little number, which is the square root of 7. That is not a perfect square, and I could not do factor tree and simplify it any, so that would be our answer. Okay, sometimes you want to separate the fraction into the square root of the top and the square root of the bottom. So number 1, 4 divided by 25. My denominator is bigger, so it's not going to give me a nice full number, so I'm just going to separate it. So this is really the square root of 4 over the square root of 25. Now I'm going to work them individually. On top, the square root of 4 is just 2. On bottom, the square root of 25 is just 5. So my answer is just 2/5. Number 2, again, square root of 7 over 9. And that's not going to divide and give me a nice whole number. They don't have anything in common that I can reduce by. So I'm going to separate square root of 7 over the square root of 9. On top, the square root of 7 is not a perfect square. I can't do factor tree or anything on it, so it stays the square root of 7. On the bottom, the square root of 9 is 3. So there's my answer, square root of 7 divided by 3. Number 3, again, square root of 11/16. The 11 and the 16 is not going to divide, give me a nice whole number. There's nothing that they will simplify by, so separate it. Square root of 11 over the square root of 16. On top, square root of 11 is not a perfect square, and I cannot do factor tree on it, so it stays square root of 11. And the denominator, the square root of 16, is just 4. So my answer is square root of 11 over 4. Then it says sometimes you want to combine radicals under the same sign and then divide. Okay? So anytime that you have radical on top, radical on bottom, you can combine those numbers. You can go ahead and divide them if they will divide. So number 1 says the square root of 32 divided by 8 square roots of 2. If I just look at my radicals, 32 and 2, well, I know I can divide that. 32 divided by 2 is 16. My bigger number is on top, so my answer goes on top. So I have the square root of 16 still underneath the radical, because all that I did was square root of 32 divided by 2. Up here, remember where we separated them? Here you can put them back. So if I put them back, then 32 divided by 2 is the square root of 16. So really I just have the square root of 16 over 8. So now on top, the square root of 16 is a perfect square, 4 over 8. But I can simplify that. That reduces down to 1/2. So here my answer is just 1/2. So let's try that again. Number 2, the square root of 63 divided by the square root of 7. They're both underneath radicals, so I can divide them. 63 divided by 7 is 9, still underneath the radical, so this is just the square root of 9. But that's a perfect square, so my answer is just 3. All right, number 3, I have 3 square roots of 14 divided by the square root of 7. Underneath the radical of 14 to 7, I can divide that. I still have the 3 out front. 14 divided by 7 is 2. There's nothing I can do with the square root of 2, so my answer is just 3 times the square root of 2. So now let's review what's called rationalizing the denominator. So to be completely simplified, there can be no radicals in the denominator. To get the radical out of the denominator is called rationalizing the denominator. In order to do that, you multiply the numerator, which is the top, and the denominator, the bottom, by the radical in the denominator that you're trying to get rid of. So if I look at number 1, 2 divided by the square root of 7. The only radical I have is the square root of 7. I can't do factor tree. There's nothing else I can do to that, but I cannot leave my answer like this because I'm not allowed to have radicals in the denominator. So to get rid of it, I multiply by that radical. But then remember, we have that rule in math. Whatever I do to one part, I have to do to the other part, so I have to multiply the top by square root of 7. So now I have 2 square roots of 7 over, remember the other day when we reviewed multiplying radicals, anytime I multiply a radical by itself, the radical disappears and I'm just left with the number. So the square root of 7 times the square root of 7 is just the number 7. I have a 2 and a 7 now not underneath radical. They're not going to simplify. Underneath my radical is a 7. I can't do factor tree, so there's my answer. So number 2, 5 divided by the square root of 3. Again, multiply top and bottom by the square root of 3. So on top, I have 5 square roots of 3 over the square root of 3 times square root of 3 is just 3. I have a 5 and a 3 not underneath radicals. They're not going to separate, or sorry, they're not going to reduce. So those are my answers. Number 3, I have the square root of 12 over the square root of 5. I cannot simplify 12 and 5. They don't have anything in common. I can't divide and get a nice whole number. So I need to just multiply top and bottom by the square root of 5. So on top, square root of 12 times square root of 5 is the square root of 60 over just 5. But now 60, I can do factor tree on. It's not a perfect square, but I can do factor tree on. I know that it just came from 12 and 5, right? 12, I could do 4 and 3, 4, 2 and 2. I have a pair of 2s, a 3, and a 5 that got left behind. So the square root of 60 is 2 square roots of 15, and then I still have the 5 in the denominator. The 2 and the 5 cannot simplify, so my answer, 2 square roots of 15 divided by 5. So now the trick is being able to identify out of all those methods we just looked at, which ones you need to do. So now our directions just say divide, and this is what our homework is going to look like. So number 1, I have the square root of 6 45ths. Okay? Well, I can't divide that and get a nice whole number, but I do know that 6 and 45 both have a 3 in common, so I can simplify this. I can reduce this. If I take a 3 out of everything, 3 goes into 6 twice, 3 goes into 45 15 times. So now I have the square root of 2 15ths, which is the same thing as the square root of 2 over the square root of 15 if I separate them. I can't have a radical in the denominator, so I'll multiply top and bottom by that radical. So on top, 2 times 15 underneath my radical is the square root of 30 over just 15. 30, lots of people think that you can do factor tree on that, but it doesn't end up with any pairs, so our answer is just the square root of 30 over 15. Number 2, the square root of 64 divided by 8. Hey, 64 divided by 8, I know I can divide that, so that's really just the square root of 8. Now I can do factor tree on that, right? That's a 2 and a 4. 4 breaks down 2 and 2. I have a pair of 2's and a 2 left behind. So 2 square roots of 2 is our answer. Number 3, I have 6 square roots of 2 over the square root of 3. 2 and 3 are underneath my radical. They don't have anything in common. I'm not going to be able to divide them. So I need to jump straight to rationalizing the denominator, multiply top and bottom by the square root of 3. So now on top, I have 6 square roots of underneath the radical. 3 times 2 is 6. Over square root of 3 times square root of 3 is just 3. But now I have this 6 and this 3 are not underneath the radical, and I can simplify that. That 3 goes in that 6 twice. So now I have 2 square roots of 6 as my answer. We look at number 4, square root of 81 over 18. That's not going to divide and give me a nice whole number, but I know that I can reduce them. They both have a 9 in common, so if I take a 9 out of both of those, I get 9 halves. So I can separate that, the square root of 9 over the square root of 2. On top, the square root of 9, well, I know that's just 3. So I have 3 over the square root of 2. I cannot leave my answer like that because of the radical in the denominator, so I need to rationalize. So I end up with 3 square roots of 2 over just 2. My 3 and my 2 not underneath radicals are not going to simplify. They don't have anything in common. So our answer, 3 square roots of 2 over 2. All right, number 5, I have 14 square roots of 10 over 7 square roots of 5. Here, I can simplify that 7 goes in that 14 twice. Underneath my radical, I can divide that. So now I have a 2 on the top. Underneath radical, 10 divided by 5 turns into 2. So just by simplifying first, I made my life much easier, and I simplified to just 2 square roots of 2. Number 6, the square root of 17 over the square root of 6. I cannot divide them and get a whole number. They don't have anything in common that I can reduce by, so I have to go straight to rationalizing, multiply top and bottom by the square root of 6. On top, 17 times 6 is the square root of 102 over just 6. I can tell very easily that I cannot do factor tree on 102. I'm not going to get any pairs because it came from 17 and 6. 17 just comes from 1 and 17. 6 is just 2 and 3. So there's no pairs there. So our answer is just the square root of 102 over 6. So number 7, I have 3 square roots of 14 over 2 square roots of 5. My 3 and my 2, not underneath radical, nothing in common. My 14 and 5, nothing in common. So I have to go straight to rationalizing, multiply top and bottom by the square root of 5. So now on top, I still have the 3 out in front. Underneath the radical, 14 times 5 gets me 70. Over, I still have the 2 out front. Square root of 5 times square root of 5 is just 5. So I'm going to multiply that. So on top, I have 3 square roots of 70. Again, I'm not going to be able to do factor tree because 14 and 5, 2, 7, and 5, nothing in common. Over 2 times 5, 10. My 3 and my 10, nothing in common, so there's our answer. Number 8, 6 over the square root of 24. The square root of 24 is the only thing that's underneath a radical, so I can either rationalize by multiplying top and bottom by the square root of 24 and then simplify, or I can do factor tree and then rationalize. I like to do factor tree first. It's a preference thing, so you do whatever you prefer, but I'm going to break 24 down. That breaks down to 8 and 3. 8 breaks down to 2 and 4. 4, 2, and 2. So I have a pair of 2s, a 2 and a 3 left behind. So really, I have 6 on top over 2 square roots of 6 left behind. Now, this 2 goes in that 6 3 times. So now I have 3 over the square root of 6. Now I can rationalize the denominator by multiplying top and bottom by the square root of 6. So on top, I have 3 square roots of 6 over just 6. But again, that 3 goes in that 6 twice. So I have the square root of 6 over just 2. So lots of simplifying and reducing in that one. Remember that if something is underneath the radical, you can only reduce it with other things underneath radicals. So don't fall into the mistake here of saying the square root of 6 divided by 2 is 3, right? Because the 6 is underneath the radical and the 2 is not. So they don't have anything to do with each other. Our last one, 10 square roots of 3 over 20 square roots of 15. The zeros cancel each other out, so really I just have 1 on top and 2 on the bottom. 3 and 15, they have something in common. That 3 goes in that 15 5 times. So really now I have 1 on top over 2 square roots of 5. Again, just by simplifying at the beginning, we can make it much easier problems and much smaller numbers to work with. Now all I have to do is rationalize the denominator. I need to get rid of the radical, so I'm going to multiply top and bottom by the square root of 5. So on top, I have the square root of 5. On the bottom, I have 2 times 5, which is 10. So our answer is the square root of 5 over 10. So then that is a quick review of dividing radicals and rationalizing the denominator, which just means getting rid of the radical in the denominator. Your homework will be exactly like this, these last examples.